Welcome to On Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. I am happy to say this is the episode number 100. We solved so far 500 problems in CSIR. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is bicyclic system. In the fused carbon you have methyl and you have the first position ketone there. You are using hydroxylamine and sulfuric acid. They ask you to find the product. The product can be ring expanded cyclic amide with CO in the first position or N in the first position or simply the ketone retainment or simply the alkene formation. So from the ketone and hydroxylamine you might guess it's a naming reaction involved. And definitely the possibility of ring expansion or ring opening is there. The answer is A. Let us see how. The starting material you have ketone and you are using hydroxylamine. So the ketone getting into hydroxylamine formation. Due to the methyl group, hydroxylamine forms strands or form away from the methyl group. So hydroxylamine is there. Next step you are using acid, sulfuric acid. It protonates the alcohol and try to remove it. While removing, Beckmann rearrangement will be happen. The trans group migrates there. Because in Beckmann rearrangement, the group which is trans to nitrogen or anti to nitrogen moves there. So it moves, the ring will be expanded. So the cation formed at the second position. The cation has to be quenched. The removed water again attack there. You have alcohol. So once you do ketone tautomerism, you have answer A, which is amine on the first and ketone on the second. So cyclic amide formation. Here you have to learn two important things. One is hydroxylamine formation. The hydroxylamine formation dictated by the steric effect here. So it's formed away from the methyl group. Second thing is Beckmann reaction. The elimination always favor in the anti position. Here even though groups are bulky, which is in anti to the nitrogen, so it moves and forms the 6-member ring. Then the question number 2. The starting metal is 6-member ketone and you have side chain which is allyl. The end alkene group is there. You are using palladium chloride and copper chloride, oxygen and water and DMF. DMF is a solvent here and you are using sulfuric acid. Here they ask you to find the product. The product can be bicyclic fused ring, which is 6-member and heterocyclic ring, or 6-member and 5-member ring, or 6-member 5-member aromatic ring, or the bridged system. So there are many possibilities. From the reagents you might guess naming reaction is involved, and definitely the ring closure possibility is the real question here. The answer is C. Let us see how. The starting metal you are having alkene, you are using palladium and copper chloride. So you might guess it's a Baker oxidation. It is an interesting oxidation because it converts CC bond into COCH3. The alkene becomes ketone there. So C double bond C getting into ketone form COCH3. Next step you are using the acid. Acid promote the ketoenol tautomerism. So you have ketone there. So intra-condensation is possible. So first carbon attack the fifth carbon. You have new 5-member cyclic ring. If you redraw perfectly, it's a 6-member bridged system. I give a number for your understanding. So the answer is clearly C there. Here you have to learn two important things. One is Baker oxidation. Baker oxidation is the important one because it converts C double bond C into COCH3. Second thing is if you have two ketones, you might think of intra-condensation. Here intra-condensation leads to the bridged system. Then the question number 3. The starting metal you are having anisole. In meta position you have methyl there. You are using sodium and liquid ammonia and tertiary butyl alcohol. Next step you are using dilute sulfuric acid. Here you have 4 products, the possibility of ketone and alkene. The position of alkene is important here, whether it is in conjugated position or near to methyl or away from methyl or just a 1,4-diene. So there are the possibilities. So from the reactant to product you might guess regioselective reduction is occur. By looking at sodium and liquid ammonia you might guess it's a naming reaction. The answer is B. Let us see how. The starting metal you are having benzene ring, you are using sodium and liquid ammonia. So you might guess it's a Birch reduction. Birch reduction always reduce the carbon which is away from the electron donating group, or you can say double bond formed near the electron donating group. So double bond is formed there near methyl and methoxy, both are electron donating group. So 1,4 double bond will form here. Then the next step you are using the sulfuric acid. The sulfuric acid remove the methyl there. So you have hydrogen. Just a ether reaction, removal of methyl group. So you have alcohol and you have nearby alkene. So you might think of hetoenol tautomerism. So you have alkene and ketone. So there can be the possibility of conjugation. System always go to the conjugation. So the dilute sulfuric acid next step you are using catalyze that bond. So conjugation is more stable than non-conjugation. So sulfuric acid protonate the ketone. You have hydrogen removal and you have again the conjugated ketone formation. Continuous charge travel leads to the charge in the fourth position. So you have charge is there, again it's conjugated by H+. So charge conjugation leads to conjugated ketone, which is answer B. Here you have to learn two important things. One is Birch reduction. In Birch reduction, double bond always form near the electron donating group. Second thing is conjugation is more stable than non-conjugation. So you have to induce the conjugation in all possible ways. Then the question number 4. The starting metal is fused system with 6 members on each side, and you have hydrogen and tosylate in syn form, hydrogen and hydroxide in the opposite. You are using the strong base KH. They ask you to find the product. The product can be ring open one and position of ketone alkene is there. Whether alkene is nearby or further away, or just a product is simple alkene formation or simple water elimination. From the reactant to product you might guess the double bond position is important. Ring opening occur or not is the real question. The answer is B. Let us see how. The starting metal is a fused system. It will be easy if you draw in the chair form. So you draw in the chair form, hydrogen and OTS should be cis and OH should be trans. So we write H and OTS above, OH below. You are using strong base. So you have the proton removal, you have anion formation. Here charge is formed and it has to be quenched. So the charge travels. So charge travels to the leaving group, which is the easy way to quench the charge. So O minus forms ketone. To satisfy the valency, the bridged bond moves to the leaving group. So OTS leaves, you have alkene formation. So you have the alkene and ketone in the system. So we have to redraw to the answer normal form. So you write the numbers and get back again. If you draw it, you have the answer B, which is E alkene. Here the E alkene is formed because the stereochemistry is preserved during the reaction. The cyclohexane hold its original form. So E alkene is there. You can see the 5 and 6 position. The E form is retained there, transformed. Here you have to learn two important things. One is charge travel. Charge always travel to the leaving group. Here it is OTS. Second thing is stereochemistry. During the reaction, stereochemistry didn't modified. So the E alkene is retained there. Then the question number 5. The starting metal is alkyne, you are using bulky boron. Then you are using acetic acid. They ask you to find the product. The product is alkene, where deuterium can be cis to each other or trans to each other, or deuterium on same carbon, geminal, or deuterium on different carbon. So there are the 4 possibilities. 2 are geminal, 2 are vicinal. Vicinal has trans as cis. That is the question. So from the reactant to product you might guess the selective reduction is occur. The role of reagent is important here. The answer is C. Let us see how. The starting metal you have alkyne, then you are using boron. So what really happened? It is like hydroboration reaction. There are the 4 possibilities. Boron can be near to the phenyl or away to the phenyl. Boron can be cis to phenyl or trans to phenyl. So the mere 4 possibilities. So borane add means the deuterium add to the other end. So you have to think which way is the major product. The major product is one is like here just a borane addition. So you might think of hydroboration. Hydroboration is the anti-Markovnikov of addition. Another way to think is the stability of cation and stability of anion. Simple way here the bulkiness of boron decides everything because it's added in the transposition due to the bulkiness as well as it will add to the opposite to pH. So the answer will be clearly C where deuteriums are trans to each other. Here you have to learn two important things. One is hydroboration reaction. It's just anti-Markovnikov addition. It can be occur in alkyne. Second thing is acid role. Mere acid can replace boron and it replaces it with hydrogen. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.